The only way to learn mathematics is to do mathematics.
So I am Francis May Pamisa.
I am Crilime Pagaran-Lago, and we are here to prove to you the Pythagorean theorem by manipulative and by some of the formal proof.
So what is a Pythagorean theorem? Pythagorean theorem is sometimes called a Pythagoras theorem. So a Pythagoras theorem is a theorem about a right-angled triangle which is named after the famous mathematician Pythagoras.
The Pythagorean theorem states that the sum of the square of the two legs of a right triangle is equal to the square of the hypotenuse. So basically, we need to prove that a squared plus b squared is equal to c squared.
Go.
I have here a right triangle. We will use ABC to label this. So this leg here is RA, and this leg is RB, and this side is RC, the longest side of a triangle, and it refers as a hypotenuse. So what Pythagorean says that the sum of the square of these two legs is equal to the square of this hypotenuse. So let's try to find out if the Pythagorean theorem is true. I have here four right triangles. We will form a square out of these triangles. So here, just like this, we will use space, and we will label this with A, B, and C, which is C is the hypotenuse of this right triangle. Here, and so there is it. We will label this as RC, the hypotenuse of a triangle. Here. The B, the A, the B, A rather, B, A, B, and A. So, out of these right triangles, we made a square. And this square composed with side C, and to get the area of this square is side times side, or also known as C squared. So, here. And this side, we should label this to prove Pythagorean theorem. We will find out the remaining legs, which is equal to this square. So now we will put the four right triangles in the same area of a square to determine the two remaining legs of a right triangle, which is the A and B. So here, to get the square, the area of the square is side times side, right? So here we will label this as our A squared, and this is our B squared. Now let's compare the two arrangements. Since that the overall area of the two arrangement are the same, in both cases we also use the A plus B by A plus B. Therefore, I conclude that the area of the big square and the small square taken together is equal to this square. So this means that the Pythagorean theorem is true.
Hello everyone, I am Francis May Pamisa. So, Pythagorean theorem applies only on right triangles. What it says is, if we have two legs, let us say A, B, and a line C, there exists a special relationship, which is A squared plus B squared is equal to C squared. So what Pythagoras is trying to say is that in a right triangle, A squared plus B squared is equal to C squared. But we cannot say immediately that yes, A squared plus B squared is equal to C squared. We have to prove it. So let's start with this. I have a triangle which has legs A, B, and a hypotenuse C. What I'm going to do now is to draw 3 more triangles with the same side as this. So I have now this is B, A, C, B, A, C, B, A, and C. All of these triangles are congruent. But how will we prove this? We will prove this by what we know about the area of a square. In this square, how will I know the area of this square? So first, I have to determine one of its sides. So we can see here that it has A, B, A, B, A, B, A, B. So basically, the area of this square is equal to A plus B squared. What I'm trying to say now is that the area of this whole square is equal to the area of its part. We have here the smaller square and the 4 congruent triangles. All of these triangles are congruent. But how will we prove this? We will prove this by what we know about the area of a square. In this square, how will I know the area of this square? So first, I have to determine one of its sides. So we can see here that it has A, B, A, B, A, B, A, B. So basically, the area of this square is equal to A plus B squared. What I'm trying to say now is that the area of this whole square is equal to the area of its part. We have here the smaller square and the 4 congruent triangles. So, how will we determine the area of this square here? We can say that this square here inside has the side C. So the area of this is equal to C squared plus the 4 congruent triangles, so 4 times height divided by 2. So A times B over 2. Now, what we will show is that the area of the big square is equal to the area of the smaller square and the area of the 4 congruent triangles. When we will simplify this one, we will arrive to the so-called Pythagorean theorem. Now, we will simplify further this equation. So, from our knowledge in algebra, A plus B, the quantity of A plus B squared is equal to A squared plus AB times 2, so 2AB plus B squared is equal to, bring down C squared, so C squared plus 4 divided by 2 is equal to 2, and then times A and B. So we have 2AB. Now, we can actually remove this 2AB so that we can already have the Pythagorean theorem. We can remove this by additive inverse. Subtract negative 2AB to both sides. So negative 2AB and negative 2AB is equal to A squared plus B squared is equal to c squared. Now, we already arrived at the Pythagorean theorem.